Hey guys, today we are going to talk about the correlation matrices and the correlation representation. So, which kind of experiments you can use this? I know that some of you are working with several data that you asked from your classmates, or even you are making a survey. And when you want to represent that, is there any relationship with two parameters, that could be a useful tool to show is there a kind of inverse or a positive relationship between the data that you have measured, or there is no correlation, which means there is no connection, whatever it is. So this method is using the so-called correlation coefficient R value, and this is going to quantify the direction and the magnitude of the correlation that you want to check. So usually every parameter has a kind of distribution during your experiments, but the most important in the case of the correlation matrix is that the two variables should be real numbers, which means that you cannot use kind of words like positive or negative or black and white, or I don't know, if you want to compare two type of car brand, it is not going to work. So every time you need to change into numbers, so it's worth to recalculate or generate a numeric legend for your experiment. And also it's important to see that these correlation analysis is going to report the value of the correlation coefficient in a sense that it is tending to the -1 or it is tending to the +1. Because if it's -1, then it means that there is an inverse relationship. So the value of the variable goes up while the other one goes down. If it's positive, it means that there is a positive relationship. Even more one of the variable of yours is, then the other one will go up too. And if it's 0, it means that there is no connection between the two parameters that you have checked. So today we are going to make an example and an experiment between parameters that you have measured, and we are going to make correlation coefficient based matrices and graphs. So now I'm going to close this one. I want to save this, and let's go into the Graphpad. So when you are in the Graphpad, the first thing you need to check is the so-called multiple variable type of graphs. So if you click on it and then click create, then you would get an empty sheet of these variables. Here you will see that you have plenty of options to type here the parameters that you have measured. But this time I'm going to work with mine, what I copied from my Excel file. I'm going to just paste in it. And as you see here, you see height, foot, nose, hands, and ego level. And as you see, I have many of data, but every column has its own data there. And also, if you take a look at here, ego level, it's really hard to measure because you would say that this is really typical or not typical, or high or low. So that's why in my case, there was a legend there, which means that if it's high, I give a 5. If it's like lower, the values are tending down to 1. But first of all, I'm going to rename my datasheet with a right click and rename the sheet. That would be the length versus the height, for example. So there are two options. You can make a graph, but also without making a graph, if you do an analysis, the program will make a graph for you. So that's the one that we are going to use now. If you click on the analyze data, then it is going to open the list of the built-in analyses. As you see here, the multiple variable analysis can give you the correlation matrix, multiple linear regression, and the others. But this time, we just go with the XY analysis and the so-called correlation. And if you click OK, then it is going to ask you, what do you want to do? First of all, it's automatically set to compute the R value, which is the correlation coefficient, every pair of the Y data set. So that makes a correlation matrix. But this means that from the length, the height, the foot, the nose, the hands, and the ego level is going to be compared and computed. But that's not good for us, because in the case of the correlation, and that's the most important here, you are comparing two type of parameters, not three, not four, just two. So we are going to click here to compute the R between the two selected data sets. The column A, that's fine. The column B, that was the height, and that was the name I typed there. So that's okay. Assume the data are sampled from Gaussian distribution. Yes. There are two options, the Pearson correlation or the Spearman correlation. However, both can work. 99% of the cases we're using the Pearson correlation coefficient because your samples are following the Gaussian distribution. If it's not, then the program will automatically offer you the no ones based on your data. But this time, let's go with this one. Also here you see the confidence interval and also the p-value style. You can set whatever you want or your supervisor wants. In this case, I'm going to use the GP ones and 4 digits. That's totally fine. And I'm going to click OK. After you click OK, then the program, it is going to give you the basic comparison between the length and the height values. And also it gives you the R value immediately. As you see here, that this is minus 0.6. So it is tending more to the -1. Also, you see that the p-value is 4 asterisks significant, and the number of the pairs was 37. So, but yeah, in that sense, that's a value what you can put in your manuscript and trying to convince the reviewer that, yeah, there was a correlation. But people are trying to get, you know, visual results. So that's why if you click on the graph here, now it says immediately how many data you have, what are the data values, and how it is represented. So first of all, I'm going to resize my graph with the right click and resize graph to fill the page. And now I need to change some of the representation. First of all, I'm going to select all of the fonts and everything, and I'm going to remove the bold thing. Also, I'm going to change the graph features. I'm going to double left click on the axis, and I'm going to change the thickness of the axis, for example, to the auto 2. That's fine. Also, I'm going to move this title a bit away from the axis here as well. And then this figure is not ready yet, because however you are representing all the data, there should be a line in a correlation representation. Without the trending line, the best fit regression, there is no way to believe that, yeah, that's a correlation matrix. So what you can do now is to click here of the analysis features there, fit align with linear regression. And then the program will ask you what you want to do. So here the basic setups, you can choose the graphing options, the compare or the constraint, whatever it is. But I'm just going this time with the basic setup. So I'm going to click OK. And now I have a trending line, because that will show you immediately how the two parameters are correlating to each other or not. So in my case, it says that even big the thingy was, the high was lower. So there is an inverse relationship. But the problem with this graph is that the line is the same color of the points. So I'm double left click in the line now, and I'm going to change the color. First of all, I'm going to change to this purple one, and I'm going to change the pattern, because correlation matrices are going to work with the dashed line ones. And I'm going to say okay. So now your graph is ready. But if you go back to this table, you have many options to compare. So now I'm going to go with another one. But for that, need to make another matrix. I need another data sheet and also the graphs, but I don't want to make all the setups. So I'm going to right click on the data. I'm going to duplicate my family. I'm going to remove the duplication layout, but I'm going to change the title length versus the, let's say, food. And I'm going to click OK. So now, not only the data sheet has been copied, but also the correlation and the data representation. But if you click on the results, as you see again, it was compared with the previous setup. So you need to change. For that, you can click with the left button on the tabular results. And then from the same setup, you need to change to the food values and then click OK. Now, as you see, the person value is different than the previous one. Take a look at the correlation graph. Whoa, okay, that's a bit different. If you see the food and the length has a kind of positive correlation because your line was going in a different way. That's good. Let's make another one. Again, you can just right-click to the original one, duplicate the family, remove the duplicate layout thing, and rename the comparison. Let's go with the nose one. Again, you need to click on the correlation, the tabular results, and change from the list to the nose. And as you see here, even it says like there is no significant difference. So if you take a look at the graph, it will say that there is no correlation. So let's make another one. Again, right-click, duplicate the family, remove the duplication, and now let's go with the ego. Again, you need to go to the correlation settings, the tabular results, and you need to select the ego from the list. If you click OK, then the graph has been made. That's a really nice representation. But also, I just want to show you another one, which will go with the hands. So I'm going to do the same thing what I did before. I'm going to choose the hands from the list, and then I'm going to click on the graph. Now that's amazing. Good. So now you have made several representations of the correlations, but some of the cases you need to make layouts. So if you click on the new layout, I'm going to represent 4 of my graphs in the landscape orientation, and I'm going to double left click in, and that would be the high, that would be the food, for example. No, let's go with the nose because that was not significant. Let's go with the ego, and let's go with the hands. So now I have 4 graphs on the same layout, but do we really need the titles like the XY data, correlation length vs ego, or the titles are also talkative? The latter is true. So if you go back to the original graph, you can remove the titles. And now go back to your layout, and as you see, now the graphs are there without the titles. So I would suggest you to enlarge the graphs because that helps you to fill up the whole canvas. So I'm going to resize one of the graph, and it is going to ask whether I'm going to change the size of the other ones or not. This time I go, yes, let's change. But as you see, my graphs are not in the same position. So I'm going to move the down part until I see that the x is y, it is in the same position. Also, I'm going to do the same thing with the other graph. And now I need to do some labeling because now I have 4 graphs and nobody knows which graph I'm going to talk about if I make a figure legend. So in that sense, you need to add titles in the form of the letters. So you can use the word settings here. So if you click on the T and then you type here A, and that would be, if you copy this, you can elaborate with the other ones, and here as well, that would be the C1, and also you can use the D to label the last one. So now it looks like that your figure is almost ready. But the thing is, this is boring. Just to be honest, right? You have a lot of spots, you have a lot of graphs, but if you want to focus, or you want to make the reviewer to focus on one of the details that you want to show, you can use colors, or you can use like highlighters, but highlighters in a graph, but that just doesn't make any sense. So if you want to lead the attention of your audience, just trying to show them what to look at. And for that, we are going to use the draw function of the Graphpad. If you click on this selecting drawing tools, you can select this rectangle with rounded corners, and then a pencil will appear. This pencil is the one which helps you to draw the rectangular corner and border to show. Now it is more focused, I would say, but still it's like a black and white thing, so it's not every time the best decision. So what I do in this case is I'm going to right click on this one, but be aware where you click, because now as you see, my selection goes with the B graph, not the D one. So I need to click on the border of this object and right click, and I'm going to fill the color, use the fill the color function. But I told you that use usually the D column for the colors. But this time, if you want to select the color for highlighting a graph, use the semi-transparent or the almost transparent type of colors. I'm going to go this way with this orange color. But as you see now, it looks like that it is in front of my graph, which is not good. So I'm going to send this back, but before I'm going to do this, I'm going to remove the border. So right click on the line and the border thickness will be none. After that, I'm going to say that, okay, right click, and then I'm going to send it back. And now my graph is more sharp now. And if I move, I'm just moving the graph, right? So what it needs to be adjusted is the figure labels, like this D part, come down, but then the B1 should be adjusted too, and the C1 too. And also I think this this filter on it, it's not that how can I say, because it is basically inside the B1, so I'm going to select the first two and I move it a bit. Yes. So now this is the way how you can make your figure catchy and you can lead the audience attention to the one that you want to show. Because here the most striking difference was the D1. And basically that's the figure that you need to export it. You can export it into the TIFF, into JPEG, PNG, in that format that you want. But now your figure is ready. So this is how the correlation matrices are done, or correlation graphs are done. And I hope that you would have a lot of options to play with these parameters. And also there is all a chance to compare the ones, for example, the nose with the hands, the ego level with the heights, and so on and so on. So go ahead and try with your own data. I hope it helps you, and see you next time.